Hello guys, welcome to Physics Vedika. So today we are going to look into one interesting concept that's nothing but acceleration. Okay, so what is acceleration and when do you say a body is accelerating? Let me show you two videos, okay, and try to understand and try to observe, okay, the difference between these two things. So what you observed in this, the first train, it's moving steadily, or you can say it's moving uniformly, right? More or less it's moving uniformly. But the second one, if you observe, it's started from rest and then it start pulling, or you can say it start increasing its speed, right? So which train is having acceleration? Can you guess? Yes, you are right. The second one. The second one is having a very great acceleration. You can say it start increasing its speed, right? So the second one is having acceleration. Yes or no? Right? A person starts running, right? It means he started from rest and then increasing his speed. So the meaning is he is speeding up. She may be speeding up, right? So it means the person is accelerating, right? You can say that the person is accelerating. Yes or no? So whenever a body increases its speed, you can say it is accelerating. But let me show you one more thing here. As you can see here, a car which is moving with a constant speed, but it's changing its direction. So can you say whether the car is having acceleration or not? Yes, of course, the car also has acceleration. Why? Because it's moving uniformly, but still it's changing its direction. It means the car is having acceleration. Why? Because when it changes its direction, you can see the velocity is changing. Understand? So this is the important point you need to keep in your mind. Whenever velocity changes, then the body will possess acceleration, right? How velocity can be changed? Velocity can be changed by changing speed or by changing direction of motion, right? So in both the cases the velocity is going to change, right? So whenever there is a change in velocity, or you can say that acceleration is nothing but the rate of change of velocity. Understand? So the rate of change of velocity is nothing but acceleration. When a body is speeding up, or when a body is slowing down, or when a body is changing its direction of motion, then also the body will possess acceleration. Okay, so what we have observed till now, right? Acceleration, right? So we have seen that whenever there is a change in velocity, the body will possess acceleration, right? So change in velocity, so you can define acceleration as, you can define it as, it's a change in velocity with respect to time, right? So we can write acceleration as change in velocity by time. So we can define acceleration as rate of change of velocity, right? And what is change in velocity means? Change in velocity means final velocity minus initial velocity divided by time, right? So this is the acceleration. Yes or no, right? If you observe here, let's say in the given examples, that train, okay, the train which is start increasing its speed, right? So if you are sitting in the train, what do you feel? You feel like you are moving backwards, right? Suddenly if train starts increasing its speed, you will feel like you are moving backwards. So that is the situation of acceleration. Yes or no, right? Now let's proceed further. So acceleration is change in velocity by time, you have written, right? And what are the units? What are the units of this acceleration? You know, change in velocity. Change in velocity means what? The units are nothing but meter per second, right? Divided by time. Time has units again seconds. So overall, you will be getting meter per second square, right? So meter per second square is the units for acceleration. Understand? Let's say if a object starts from rest and increases its speed to 10 meters per second, 10 meters per second, right? In 2 seconds, let's say in 2 seconds. Let's say this is a case 1, okay? Then there is a second case. An object travels from rest and increases his speed to 100 meter per second in again 2 seconds only. So what is the difference you are going to observe here? You will see that the first person or the first object, what is the acceleration it has? We know how to find acceleration: change in velocity by time, right? So that will be 10 minus 0 by 2. So that will be 5 meter per second square. Then what is the acceleration in the second case? It will be 100 minus 0 divided by 2. So that will be 50 meter per second square. Yes or no, right? So acceleration in the first case is 5 meter per second square. Acceleration in the second case is 50 meter per second square, right? And also if you try to understand here, if a object has an acceleration of 5 meter per second square, it is increasing its speed slowly, yes or no, from 0 to 10. But if an object has an acceleration of 50 meter per second square, then we can see that its speed is increasing rapidly. In 2 seconds itself, its speed changes from 0 to 100. So that is a way you can understand what happens if a body has more acceleration. If it has more acceleration, then its speed will increase drastically. Within less time, the speed will go to very high value. Understand, right? So that's the thing you need to know about acceleration. Okay, dear children, let us look into some interesting questions on acceleration. That is average acceleration we are trying to calculate now. So let us see the first question. A toy car accelerates from 2 meters per second to 5 meters per second in 6 seconds. What is its acceleration? So how to find out this? We know that what is the formula for acceleration? Acceleration, we know it is change in velocity divided by time. So change in velocity means final velocity minus initial velocity. That is nothing but change in velocity divided by time interval. So what is the final velocity here? The car is accelerating from 2 meter per second to 5 meter per second. It means 5 meter per second is the final velocity and 2 meter per second is the initial velocity, and time taken is 6 seconds. So just substitute these values. So 5 meters per second is the final velocity minus 2 meter per second is the initial velocity divided by 6. So that will be 3 by 6, or we can say it is 0.5 meter per second square, right? So this is the answer for this particular question. Hope it's clear. Let's look into the next question. Average acceleration is calculated by. So how we can calculate the average acceleration? As I told you just now, the average acceleration is change in velocity divided by time, the time interval. So look at the options here. As you can see, velocity change divided by elapsed time, that is the proper answer. So we can mark option C as the correct answer. Understand? Remaining options are not correct here. Now let's look into the next question. How long does it take to accelerate an object from rest to 15 meter per second if the acceleration was 3 meter per second square? Very nice question. What he is saying here, it has to accelerate from rest to 15 meters per second, right? It has to accelerate from rest to 15 meters per second, and also given acceleration is how much? 3 meter per second square. This is given. Then what they are asking you to calculate how long does it take. It means they are asking you to calculate the time. So how to solve this question? We know acceleration is change in velocity divided by time. So that's the reason. Substitute the given quantities. Acceleration is given as 3 and final velocity is 15. Initial velocity is 0 divided by time. So based on that, we can say this is 15 by t. Then what is your t? It is 15 by 3, and that will be 5 seconds. Yes or no? So the correct answer is option C. Is that okay? If you don't understand, you can again go back and look at the solution, or you can better pause the video and try the question again, and then do the or look at the solution. Okay, so that is how you need to solve the questions. So I am giving one more question for you. Just pause the video and try for this, then verify the solution. Look here, what they are saying. How long does it take for a car to change its velocity from 10 meter per second to 25 meters per second if the acceleration is 5 meter per second square? So how to solve this one here? Again, use the formula. Acceleration is change in velocity divided by time. So it's given that acceleration is 5 and the final velocity is 25 and the initial velocity is 10. So again they are asking for time. So just substitute the values, given quantities, then what you are going to get? 5 equals to 25 minus 10, that will be 15 by t, then t equals to 15 by 5, then that's nothing but 3. So it is 3 seconds. Understood? So let us look into this question now from NCERT, right? So as you can see, starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meters per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. So you can see that initially, starting from the stationary position, pedals his bicycle to attain a velocity of 6 meters per second. Stationary position means what? Initially its velocity is 0, then finally his velocity is 6, and 30 seconds of time, right? So what is the acceleration in the first case? Acceleration is change in velocity divided by time. So that will be 6 minus 0 by 30, right? Yes or no? So that will be 0.2 meter per second square. Yes or no? Then look at the second case. What is the second case? It's given that he applies brakes such that velocity of bicycle comes down to 4 meter per second. It means from 6 meter per second means he moved from position A to B, right? Then he moved from position B to C. He moved from position B to C. So when he is moving from B to C, we can see that from 6 meter per second, the velocity has become 4 meter per second because he applied brakes in just 5 seconds. Then what is the acceleration in the second case? It will be change in velocity. So initial velocity is 6, final velocity is 4. So what is change in velocity? 4 minus 6 divided by 5. So that will be minus 2 by 5. So that will be minus 0.4 meter per second square. So what is the meaning of the acceleration as minus 0.4? Right? So this is the thing which you need to understand now. This is nothing but a retardation. Right? You can see there is a negative acceleration here. That negative acceleration, you can say that retardation, or this is also known as deceleration. Negative acceleration or retardation or deceleration, these are the things which you need to understand here. If speed of object increases, then you can say it is accelerating, right? In the similar way, if its speed is decreasing, then you can say it's deceleration or it's retarding. As you can see in this question, in the first 30 seconds, the speed is increasing from 0 to 6, so the body is accelerated. Then the next 5 seconds, the speed is decreasing from 6 to 4, right? So it is decelerated. So basically, if somebody applies force in the opposite direction of motion, then the body will decelerate. Okay? Okay, so let us look into this two tables here and tell me what is a uniform acceleration means and what is non-uniform acceleration means, right? As you know, what is uniform and what is non-uniform? So from these two tables you can easily see. If you look at the first table, you can understand at t equals to 0, the velocity of the particle is 0. Then at t equals to 1 second, the velocity of particle is 4. And at t equals to 2, the velocity is 8. So t equals to 3, it's 12. And t equals to 4, it's 16. It means the velocity change is constant or you can say velocity is increasing uniformly, right? What is the acceleration you can find in this particular case? If you find acceleration from here to here, how much you are going to get? Change in velocity. What is the final velocity? 4. What is the initial velocity? 0. What is the time? 0 to 1, 1 second. So you will get acceleration as 4 meter per second square, right? But if you find the acceleration in this case also, how much you are going to get here? Let me check. Acceleration is change in velocity. What is the final velocity? 12. What is the initial velocity? 8. And what is the time? From 12 to 8, you are getting 1 second of time. So that means 12 to 8, you are getting 1. So acceleration is again 4 meter per second square. You take any two intervals, you will get the same acceleration, right? So it means the body is having uniform acceleration. Okay, uniform acceleration means it's a constant acceleration throughout the journey. That's it. Okay, understand? Now let's look at non-uniform. Whether it is non-uniform or not, how you can understand? Let me find the acceleration between these two portions here. How much I am getting? Change in velocity. What is the final velocity? 1. What is the initial? 0. By time is 1. So I am getting acceleration as 1. Very good. Let me find acceleration here. How much I am getting? 7 minus 5 divided by 1. So I am getting 2. Oh, so acceleration is different here. Initially acceleration is different and later acceleration is different. So acceleration is different at different times. It means the body is not moving uniformly. It is moving non-uniformly. It is moving with non-uniform acceleration. It is moving with non-uniform acceleration. So this comes to be under uniform acceleration, not uniform motion. Understand? Okay, uniform motion is very different from uniform acceleration. Uniform motion means what? Constant velocity, and acceleration is 0. Okay, these points are very, very important. Watch my video of uniform motion, you will understand. Okay, and this is non-uniform. Non-uniform motion? No, it's non-uniform acceleration. Understand? So this is the difference between uniform acceleration and non-uniform acceleration. Uniform acceleration means constant acceleration. Non-uniform acceleration means variable acceleration. That's it. Understand? Okay, so that's all about acceleration. I hope you understood everything, right? Whenever there is a change in velocity, then there will be an acceleration, right? And negative acceleration is also known as retardation. And what is uniform acceleration and non-uniform acceleration also we have seen, and we have seen several questions, right? So hope you like this video, and please do get subscribed for more videos. Okay, bye bye, see you.